Howdy everyone, Dr. Regev here. So, you remember that I announced in the academy that I'm going to start building tutorial with actual radar hardware, tutorials with actual radar hardware, and thus our community can purchase this type of radar hardware uh, and just learn radar by doing, not only theory like it so far was in my courses. So this is the first tutorial that I show. It's a Range-Doppler map together with CFAR detections. It's running on this radar. It's running on this radar. This is the Radar Hat Plus radar that you can purchase with a major discount in my academy. It's basically a hat on top of a Raspberry Pi 5, and you write all of the applications on Raspberry Pi 5, and it's running natively on the Raspberry Pi. Okay, so I'm just holding it right now, and it's actually running as I hold it. Okay, so if I go back and forth, you can see the Doppler. You can see the reflection from my monitor, right? It bounces off my monitor, and you can see the Doppler in the left-hand side, the range Doppler in the left-hand side, and you can see what is detected on the right-hand side. That's after a CFAR detection. Okay, so you can see this blob of pixels is detected. Sometimes there is some multipath here as well. So other stuff is detected as well when stuff is moving. But this is how it looks like, and everything is in Python. I am still in the process of writing a proper SDK for this radar. It's already up and running. You guys can also already run some Python scripts that I prepared. You can run some Python notebooks on offline data that we saved and stuff like that, and learn radar by doing. And we will go through all of the courses that I've built in terms of the FMCW theory, and I will slowly but surely publish tutorials for each and every part of the signal processing chain, so you guys can not only run the demos but also use this SDK, which is a signal processing stack, to build your own applications if you want. Let's see how this looks like. This is a corner reflector. Let's put it in front of the radar. You see that it's a big reflection, right? By the way, this is in an MTI fashion. There is an MTI filter running, so you don't see the DC, the Doppler zero type line that you usually see when a range Doppler map is presented. Also, it's not only DC, it's also in the proximity of DC. It's an alpha filter, so you guys can read the markdown files that I prepared and understand exactly what it is in the signal processing chain. But you can see this. You can see this target. You can see now I put it closer to the radar very slowly, so it's negative Doppler, very low negative Doppler. Let's take it back. So the range is increasing. It's a very low positive Doppler this time. Okay. Now if I do it fast, you see that it's reacting fast. Also, there are multiple reflector here, not from this, but from the wave is getting here and is reflected to other scatterers and back to the radar, back to here and back to the radar. So there is multipath. Okay, let's see what happens when I wave my hand. Okay, you can see it's clearly in the Doppler. You can see it rotating basically. When I approach the radar, it's negative Doppler. When I away from the radar, it's positive Doppler. It's also getting closer and further, closer and further, closer and further. It kind of look like a human doing rotations, right? So you guys will be able to access it once you purchase the radar. I will produce an image that you will basically put on the Raspberry Pi. You will image the Raspberry Pi with my image, and you will get everything inside this image, and that's it for now. I just wanted you guys to show you that progress, and I will roll out more demos and more good stuff with this radar in the upcoming weeks. All right, until next time, Regev out.